All right, everybody. So what we're going to be covering for this next month and a half is trig. I'm going to review with you special right triangles, but in a little different way than you might not be used to seeing them. But it's going to more or less still make the same amount of sense. Special right triangles are 30, 60, 90 degree triangles and 45, 45, 90 degree triangles. Now you probably remember these from last year. A 30, 60, 90 degree triangle. In the notes say this. It says that your shortest leg is half the size of your hypotenuse, or your hypotenuse is twice the size of your shortest leg, and your longer leg is your short leg times root 3. That's a 30, 60, 90 degree triangle. Okay? Now, 45, 45, 90 degree triangle. These are set up two different ways, but the way that we're going to focus on right now is, let's say your hypotenuse is a number, because normally it's x root 2, but we're not going to do that. We're going to say if this is x, this is half of x times root 2. Half of x times root 2. Okay, but I'm going to break this down a little more. I'm going to say, let's pretend now, from now on, our 30, 60, 90 degree triangle, my hypotenuse is always a 1. Or my 45, 45, 90 degree triangle, my hypotenuse is always 1. So this is 30 degrees, this is 60 degrees, and these are 45 and 45. Okay, well, according to this pattern, if my hypotenuse is 1, so remember, it's not 2 times this number, this is always half the size of this. So if this is 1, this would have to be 1/2. And my shorter leg is this times root 3. So 1/2 times root 3 is root 3 over 2. Or 1/2 times root 3, which is root 3 over 2. So in a 30, 60, 90 degree triangle, if your hypotenuse is 1, which we're going to look at why it's always going to be 1 in a little bit. If your hypotenuse is 1, the side across from your 30 degrees is always 1/2. The side across from your 60 degrees is always root 3 over 2. And the same thing with this. If this is 1, this is half of 1 root 2, or root 2 over 2. Half of 1 times root 2, which is root 2 over 2. Okay, the reason why this is 1 is because you guys might have heard about trig. You have something called a unit circle. All that means is, in an XY coordinate plane, if you have a length of 1 and this travels 360 degrees, you actually have something called a unit circle, where your radius is 1. And every time this lands on a point, it creates a right triangle. Now, what we're going to be talking about are 3 different triangles. Let's say this is 30 degrees here. Then it would follow this type of triangle where your radius is 1. Across from this would be 1/2. And this is 60 degrees, because here's your right triangle. It would be root 3 over 2. That's what it looks like in the drawing in your notes. Same thing for a 45, 45, 90. Let's do this for a 45, 45, 90. Now this is 30 degrees. 45 would be a little further up, be halfway. Boop, right here. This would be 1. And if I made this a 45, 45, 90, this is 45 degrees. Because the way this moves from the center up, that tells you how many degrees it is. This is a 45, 45, 90. And if this traveled all the way around 360 degrees, you would actually have a unit circle. So if this is 45 degrees, this is 1. Look, root 2 over 2, root 2 over 2. So across from the 45 degrees is root 2 over 2. If you were trying to find the length of this. If you're trying to find the length of this, it's root 2 over 2. That's in the other part of the notes. Going on to a little more in depth with this lesson or with this concept, I'm going to be asking you later on, what is cosine, what is sine, and what is tangent of, let's say, 30 degrees. Now remember, so, ka, toa, this is from last year. Sine equals opposite side over hypotenuse. Hopefully this is kind of coming back to you guys. Cosine equals A is adjacent over hypotenuse. And tangent equals opposite over adjacent. Okay, so let's take this. Let's take this 30 degrees. What if I were to ask you sine, cosine, and tangent of 30? Well, sine is opposite over hypotenuse. So if you were to go sine opposite over hypotenuse, 1/2 over 1 is equal to 1/2. So if you plug sine 30 in your calculator, it's going to spit you out 1 over 2. That's why. That visual drawing is why. If I were to ask you what's cosine of 30 degrees? Cosine in this triangle is adjacent over hypotenuse. Root 3 over 2 is, root 3 over 2 over 1, because adjacent over hypotenuse is root 3 over 2. So if you were to plug this into your calculator, cosine of 30, it would give you the exact same answer as whatever square root of 3 divided by 2 is. Now, what if I were to ask you tangent of 30 degrees? Tangent of 30 is opposite, which is 1/2, over adjacent, which is root 3 over 2. So this is 1 over 2 times the reciprocal. Remember, this is flipped. 2 over root 3. These two cancel out, and I get 1 over root 3. But remember, I cannot have 1 over root 3 because I have a root on the bottom, so I have to do that thing by simplifying it, by multiplying it by a special form of 1. So 1 times root 3 is equal to root 3. Root 3 times root 3 is the square root of 9, which is just 3. So if you were to plug tangent of 30 degrees into your calculator, it's going to spit you out the exact same answer as whatever square root of 3 divided by 3 is. Now let me go over the same concept with tangent. Not with tangent, with 45, 45, 90. If I were to ask you, what is sine of 45, cosine of 45, tangent of 45? Pause the video real quick and see if you can figure out these values. Okay, if you pause the video and tried it, sine of 45 is root 2 over 2 over hypotenuse, which is just square root of 2 over 2. So if you plug in your calculator, sine of 45 is going to give you the same value as root 2 over 2. Cosine is the exact same thing, is root 2 over 2, because adjacent, root 2 over 2 divided by your hypotenuse, adjacent over hypotenuse, is just root 2 over 2. Now, tangent of 45 degrees is always equal to 1, always. The reason why is because it's tangent of 45 is opposite, root 2 over 2 divided by adjacent, root 2 over 2, giving you, simplified, root 2 over 2 times the reciprocal, 2 over root 2. This and this cancel out to give you 1. That's why when you press tangent of 45 in your calculator, it spits you out 1, because in a unit circle, 45 degrees, adjacent side over hypotenuse in a right triangle is always equal to 1. The ratio of that is. Okay. Now, the next part of your notes, I talk about finding an angle, and I say whenever you are finding an angle, you do the inverse. So let's say this is 43 degrees, and it's 43, not degrees, and this is 50. And you need to find this side, or to find this angle. Whenever you're finding the angle, you always use the inverse. So from this angle, this is your opposite and this is your hypotenuse. So sine inverse is 43 opposite over hypotenuse. That's what you plug into your calculator, and that's going to spit you out the angle. Okay, a couple more things. And this is review, and I just want to review this. This is last semester. It's going to ask you reviewing graphing. Let's say x minus 2 to the third. Let's say x minus 2 to the fourth times x plus 1 squared times x plus 3. And it says graph this. If you remember from last semester, you have to graph this. This is a 4, 6, 7th root. So 7th root is going to start low and it's going to go high. It's an odd powered function. So if you were to plug x minus 2 to the 4th times x plus 1 squared times x plus 3 to the 1st, technically, 4, 6, 7. And your shape is a positive, so it's going to start low and go high. Now, remember how to graph this, because I'm going to give you a couple of questions about this, and you're going to have to remember how to do it. So you have a root of 2. You have a double root of -1. And you have a single root of -3. Okay. Now, we're going to figure out my y-intercept as well. If I want to figure out my y-intercept, I plug, you should remember, plug is 0 in for your x. So 0 minus 2 is -2 to the 4th is 16 times 0 plus 1 is 1. 1 squared is 1. 0 plus 3 is 3. 3 squared. So we're going to have a y-intercept of 0, -48 and 0, 48, which is way up here. Okay, so let's graph this now the best that we can. This is a normal root, so it's going to go up through this. And this is a double root. Double roots, remember, bounce off of. So it's going to come up, it's going to come down, boom, and bounce off. It's going to come up to my y-intercept, and it's going to go down. And 4th root means it gets flatter for a little longer and a little longer pass before it bounces. This is what this graph is going to look like. Okay, I'm going to give you guys one to try now. This is from last semester because I gave you a couple questions about this. I'm going to have you guys graph this. Y equals -x plus 4 squared times x minus 1 cubed times x minus 3, 5. Let's just leave it like that. See if you can graph that. Pause the video and see if you can graph that. Okay, let's figure out what kind of root this is, or what kind of graph this is. This is 2, 3, which is 5, 6. So this is a 6th root. It's going to be a parabola, but this is a negative, so it's going to be going down. So it's going to start low and end low. Let's do my roots. -4, I have positive 1 and positive 3. Okay. So remember, double roots bounce. So it's going to start low. Oh, let's figure out my y-intercept. I'm going to plug a 0 in for my x. 0 plus 4 is 4. Squared is 16. 0 minus 1 is negative 1. Times, negative 1 to the third is negative 1. 0, this is going to be the same thing, 48. Anyways, 0 minus 3 is negative 3 to the first is negative 3. It's going to give me positive 48. 0, comma 48. That's my y-intercept. All right. Now I can graph this. I know it's going to start low. This right here is a double root. So this is normally going to be a 0, comma 48, but see this minus sign? This makes it a negative 0, comma 48. It's a negative 48. So it's not going to be up here, it's down here. Okay, now let's figure out this graph. This is going to start low. It's going to bounce off of x plus 4 squared. It's going to come back. It's going to hit cross 48. And x minus 1 to the third means it's going to come. It's going to go flat. It's going to stay flat. It's going to come back up. And it's going to go through negative 3. The graph is going to look something like that.